Okay, today we're going to talk about a theorem that you definitely should know from elementary school, but it's so important we're going to review it. It's called Pythagorean theorem. There's a whole history lesson in here about the Greek philosopher, mathematician, logician, Pythagoras, but we won't get into that. But the theorem, and remember, what does a theorem mean? It's a rule that's always true under all circumstances, okay? So the theorem was discovered this way. It's basically found that if you draw a right angle triangle, so we got this right angle triangle right here in red, right? That if you draw a square off of each side of that, so we have a square that has side lengths equal to the length of each side of that triangle. So this triangle has like 1, 2, 3, 4, right, by 4. So it's a 4 by 4, right? So 4 times 4, it would be 16, right? So there's the area of that square, length of 4 times 4. So instead of saying 4 times 4, we could say 4 squared, right? Because 4 times 4, that's what that means, right? So we're just multiplying, we're finding the area of a square, length times width, right? 4 times 4 is 16. What about this side here? It's 3 times 3, right? Length of 3, width of 3. So 3 times 3 is the same thing as saying 3 squared, which is 9. 16 and 9. What about the last side here? It's 5 by 5, right? It's a square. So again, 5 times 5 is the same thing as saying 5 squared, right? Which gives us 25. So it happens to be with every single triangle, every single right angle triangle, got to be clear, sorry, no matter what, as long as it's got that right angle there that I'm trying to draw in right there, right? That if you add the area of the two smaller sides, so what were the smaller sides, right? 16 and 9, those are the smaller sides, right? If you add those together, they will always equal, if you get their sum, they'll always equal the area of the bigger side, which is 25. No matter what, it always works, okay? So that's why it's called a theorem. It always works, and it's called Pythagorean's theorem or Pythagoras theorem. So what we can do is we can use this to solve for missing sides, right? So generally what we use is a squared plus b squared equals c squared, right? This side being the C, right? We usually label the longest side across from the 90-degree angle as C, the hypotenuse, okay? So in our formula, it doesn't really matter which side of the equal sign it's on, but notice how it's by itself, okay? So that's a key thing. The hypotenuse is the name for the longest side of the right angle triangle. It's always across from the 90-degree angle, okay? So that's going to be the one that's always alone. Sometimes we know it, sometimes we don't. The other two sides are interchangeable. You call them A and B, it really doesn't matter, okay? A squared and B squared, right? Now, again, why are we squaring it? Because remember, we're finding the area of each side, right? So if we draw a square off of each side and you square it because it's length times width, but the length and width are the same, okay? And that gives us our formula. So let's show how we can use this to find the missing sides of a triangle. Super important that we have to know this. Very, very important. Okay, so now essentially there's two scenarios that can occur. Either we know the hypotenuse or we don't have the hypotenuse. Most of us get the first one right. We usually don't have any problems, okay? So don't have the hypotenuse. How do I know I don't have the hypotenuse? Because the hypotenuse is the side across from that 90-degree angle, and that's our unknown, right? So what we do is, what I would tell you every triangle you do, the first thing you should do is label the side across from a 90-degree angle as C. The other two sides can be A and B. It doesn't matter who's A and who's B, okay? So there you go, C, A, and B. So let's write our formula. C squared equals A squared plus B squared. There's our formula, okay? Now we don't know what C is, so I'll just label it C. Now sometimes the question, it might be an X or something. You want to make it an X, fine. But as long as you know where to put the numbers in the formula, okay? Because the hypotenuse side is always the side by itself. The other two smaller sides are always together on the other side. All right, so to solve for C, what we have to do is go, well, what's 5.2? Square it. What's 3.7? Square it, and then add them together, and let's see what we get. Now, just to spare you calculator time, I did a lot of these calculations already. Let me just pull them up here. I got them on my paper. Okay, so 5.2 squared. Again, well, let me look at the calculator real quick, because some of you might like, what button do I hit, right? Okay, 5.2 squared. I can either go 5.2 and then hit my square button here. It says x squared like that. Or if I don't have that, I can just go, what's 5.2? Oops, clear that out. 5.2 times 5.2. It's the same thing, right? Either case, I get 27.4. Do not round. This is a big thing in this unit. Don't round anything till you get to the very end, okay? So really important. This is for everything. Like, this is our final unit, measurement stuff. It's Pythagorean theorem. It's going to be area, perimeter, volume, all that kind of stuff, okay? So don't round anything in any of the questions till you get to the very end, all right? So we can maintain as much accuracy as we can. All right, so now 3.7 squared, or 3.7 times 3.7 is 13.69. All right, we're going to add those two together, right? And that's going to give me 40.73. Now, do you remember what we do here? This is what c squared is, right? But we want to know what c is. So what's the opposite of squaring? Is the square root. So if I square root this side, it cancels out the square. Then I have to square root the other side to keep it balanced, right? So we're going to go to our calculator here again, and let's pull that up, and I'm going to put in 40.73 and then hit square root of that. So square root button is sometimes hidden above the x squared button on your calculator. You might have to hit shift or second. So I'm going to hit second and then square root. See that one right there? And what do we got? 6.382. And we're going to round all our final answers to one decimal place. Okay, so let's just make it 6.4 approximately. Put a little dot there to say it's approximately. And we're dealing with units or centimeters. So there you go. There's your missing length, about 6.4 centimeters. All right, so that one's generally the one everyone does really well on, and this is the one where we have the most issues. Although, let's be honest, it's not that hard. It's just got to make sure we label the sides correctly. The side across from the 90-degree angle is c. If you get that right, you're going to get the rest of the question right. So c squared equals a squared plus b squared, right? Now, who do you want to make a and b? Doesn't matter. He can be a, he can be b. It doesn't matter. We're solving for the missing side. It doesn't matter whether we label it a or b. So the 17, notice, is alone on that side, right? The 15 is going to be a, and we're going to solve for b. All right, so we need to square the 17. So if you go 17 times 17, you get 289. If you square the 15, you get 225. Now, what's the difference between this one and the previous question? What's the difference between these two? In this case, right, the two numbers were on the same side, so I added them, right? After I square them, I should say. I added them. Well, in this case, we need to subtract the 225 to get rid of it from this side. So instead of adding, all we're going to do is subtract. And that's the only difference, right, when you're solving for one of the non-hypotenuse sides. Notice how we're going to have to subtract. So 289 minus 225 gives you 64. Now, b squared is 64, but I want to know what the length is, not the area of that square off the side. So we take the square root of both sides, right? Square root of 64, square root of b squared. And why are we taking the square root? To get rid of the square, so that it's not b squared anymore, but b. But remember, to keep an equation balanced, whatever you do to one side, you do to the other, we're going to get 8. So there you go. The side length down here is 8 centimeters. Okay? All right. Let's check out two more of my kind of favorite test questions, and it'll be a pretty short lesson because this is something you're supposed to have covered a lot in grade school, okay? Okay, this next question involves a cone, and you're going to find when we get into a lot of questions next week involving cones and pyramids, they almost all involve Pythagorean theorem. Why is that? Because look, there's a right angled triangle inside here, right? So if I highlight it here, let me just get out a little bit of a darker highlighter. You can see there's a right angled triangle. There's two of them, right? One on each side. We'll just look at this one here since this is where all the numbers are labeled. All right, so if we pull that triangle out, I know I'm doing kind of a sloppy job, but there we go. All right, so this side is 6. This side is h for the height. What is the length of this side? We got to be careful, okay? Whenever they draw a dashed or a solid line or whatever all the way across, we are always going to assume that that is the diameter of that circle. So there's a circle at the top of this cone, right? We're going to assume, let me just draw it down here, right, that the diameter of that circle is 5. So the radius halfway across would be half of that, 2.5. So this is actually 2.5. So how do I know that? From looking at a million of these, anytime they draw the line all the way across on a question, we always assume that's the diameter. If they had only drawn it halfway across and didn't include like this part, if they had only drawn it, you know, from here to here, we would assume it's the radius. So keep that in mind when you're making your assumptions. All right, so here we go. Let's write out our formula. C squared equals a squared plus b squared. Now, the most important thing is which side is the c. The c is across from the 90-degree angle, so c is going to be 6, right? So I'm going to make this 6 squared. Now, the other two can be a and b. It really doesn't matter who's a, who's b, so you can be a, you can be b. So I'm going to go 2.5 squared plus h squared, right? And away we go. So let's do this. 6 squared is 36. 2.5 squared is going to be 6.25 plus h squared. Now, once again, we need to get this value off of this side, right? So we're going to subtract it. If we subtract it, it's gone. But if you subtract something from one side, you have to subtract it from both sides to keep it balanced. So in other words, it disappears from this side. You subtract it from the other side. We're going to get 29.75. All right, and then we're going to go to our calculator and hit the square root button. Square root of 29.75 is going, oops, I forgot my square there, right? We're going to have to take the square root, and you're going to get about 5.45. So we'll say it's approximately 5.5 centimeters is the height of this cone. Okay, so just be, as soon as you see a cone or a pyramid, and we'll talk more about pyramids later too, be suspicious because you generally need to use Pythagorean theorem. Okay, one more question and that's going to be it. Okay, one final question here involving right angle triangles. I could do these all day though. There are so many, like I could do this for 2 hours and show you so many different questions. So the lesson here is you got to know how to use your Pythagorean theorem. As soon as you see triangles in a question that involve a right angle, right, and we got one right here, immediately you should be suspicious in your homework for this week and next week that you're probably going to have to use Pythagorean theorem. Like 9 out of 10 questions that involve right angle triangles, you're going to. Probably more than that. Okay, so they want us to solve for x in this question, right? So let's look at this. There's two triangles. There's a little triangle inside. Now look, this little triangle, we have no idea what the bottom is. We know the height is 2.2. We don't know what x is, and we don't know what this bottom here is, right? But notice how it has these little hash marks, right? Well, that means this and this are the same length, right? From here to here and here to here. Well, if you add those together, that gives you the base of the big triangle. So that's where we're going to start. So let's start by solving the big triangle. So let me just write out, I'm just going to write number 1 up here. I'm going to write big triangle. All right, so the big triangle, right, this is really poorly drawn. It's got 6.4, 2.2 for this side, and let's just call the bottom y since we're already using x, right? Okay, so all across the bottom, that's talking like all the way across from here to here, okay, is what we're looking at. So we're kind of pretending this line doesn't exist right now. We're just looking at the triangle without that line, okay? All right, so let's do our Pythagorean theorem. C squared equals a squared plus b squared. Now, which side is the c? It's the 6.4, right? So I got to make sure I get that in the right place. The other two are a and b. It really doesn't matter, so I'm just going to make the a the y and make the b the 2.2. All right, so let's start squaring stuff, right? First, we're going to have to go, well, what's 6.4 squared? That is 40.96. Don't know what y is. 2.2 squared is 4.84. All right, we're going to have to subtract that from both sides. 40.96 minus 4.84. Right, gives me y squared. Let's subtract those, which is going to give me 36.12. And then we're going to have to take the square root of that, right? So I'm kind of picking up the pace here and the number of steps I'm showing. All right, so when we do that, we get approximately 6.009 something. Okay, so it's almost 6, right, if we break it down. So all the way across from here to here, we're going to say is about 6 meters. Okay, a little bit more, but it's rounded to 6.0, right? Now, these hash marks mean we can cut it in half, right? Because they're the same length. So what's 6 cut in half? This would be 3, and this would be about 3, right? That's how long each of those would be. So I took the 6 and cut it in half. All right, so now we can focus in on the little triangle here again. Let's look at this guy now. So if I look at that triangle, right, let me just draw him separately here. Here's step 2. We'll call him little triangle. All right. Well, this bottom here is about 3. There's the x, there's the 2.2. Guess what? We're just going to use Pythagorean theorem a second time. So the reason I'm doing this is to show you that a lot of times you're going to have to find something before you find something else. Like you're going to have to go through the steps. You know, what can I find that I can use elsewhere? All right, so which side is the c? It's the x, right? So we got to make sure that is identified properly. So I'm going to replace c with x squared. The other two sides are a and b. Remember, it doesn't matter who's who. So 2.2 squared plus approximately 3.0 squared. All right, so x squared equals, what are we going to have? About 4.84 plus 9. You're going to add them together and take the square root of them. So 13.84. And when we square root that, we are going to get x is approximately 3.7 meters. Okay? So I used Pythagorean theorem 2 times in that question, right? All right, so there's a few examples just to get you going, get you thinking about it. Make sure you try the homework. Pretty important stuff with this Pythagorean theorem, okay? Thanks for watching.